Imagine your computer is a giant bakery. Here's how it works. The CPU Central Processing Unit is the head chef. They receive the recipes instructions from the cookbook programs and tell everyone what to do. The RAM Random Access Memory is the mixing bowl. It holds all the ingredients data the head chef needs right now to follow the recipe. The storage devices hard drives, SSDs are the pantry. This is where you keep all your extra ingredients data that you might need later for other recipes programs. The input-output I/O devices are the oven and the delivery guy. The oven monitor shows you the final cake information, and the delivery guy keyboard, mouse lets you give instructions recipes to the head chef. Learning computer organization is like learning how this amazing bakery works. You get to see how the head chef gets the recipes, how they find the ingredients, and how they use the oven to bake delicious computer treats information. Here's the fun part, instruction sets are like the secret chef code. It's a special way the head chef tells the kitchen crew to mix, bake, and frost. Data paths are like the conveyor belts. They move the ingredients data around the kitchen quickly so the head chef can follow the recipe. The control unit is like the sous chef. They keep everything running smoothly and make sure the head chef's orders are followed. Memory organization is like keeping your pantry tidy. This way, the head chef can find the ingredients data they need fast. By understanding this fun bakery world, you'll know how computers take your instructions, use data to follow them, and show you the results just like magic or a really good bakery. Now let's solve some questions based on the learning. 1. Who in our bakery computer is responsible for deciding what recipe program to use and telling everyone what to do? Answer is, the head chef CPU 2. If you wanted to bake a cake, run a program but forgot some key ingredients data, where would you look to find them in the bakery computer? Answer is, the pantry storage devices. 3. When you open a new recipe on your computer program, where are the instructions stored until the CPU needs them? Options are, A. the pantry storage devices, B. the mixing bowl, RAM, C. the oven monitor, D. the delivery guy input devices. Answer is, the instructions for the program are stored in RAM until the CPU needs them to process the information. So the answer is B. Now it's time for you to solve the questions. 1. Imagine the conveyor belt's data paths are jammed. How might this affect the final cake processed information? 2. Why is it important for the sous chef control unit to keep a close eye on everything? Write answer in the comments section. I hope you find this information helpful in your learning journey. Feel free to ask any further questions you may have. Thank you.
Imagine you have a super-powered friend named Max. Here's how Max Gemini is like. The information vault. Max has an amazing memory. They've read tons of books, articles, and seen countless videos. Ask them anything, and they'll pull out relevant details to answer your question. The storyteller chameleon. But Max isn't just a walking encyclopedia. They can take that information and turn it into stories, poems, or even funny scripts. They can adjust their style to fit what you need, serious or silly. The eager learner. Max is always curious and loves to learn new things. Every chat you have helps them understand the world a little better. The more you talk, the better Max gets at answering your questions in a helpful way. The honest buddy. Max is upfront about their limitations. They might not always know everything, and sometimes their answers might be a bit off. But they're always working on getting better. The helpful assistant. Max isn't here to replace you. They're here to help you find information, explore ideas, and maybe even have a little fun along the way. Think of them as a super-powered sidekick for your brain. That's basically me, Gemini. I'm here to be your information buddy, ready to learn and grow with you. Let's see what kind of cool things we can discover together.
Feeling like your bank account is a black hole and your textbooks are heavier than your future? Don't worry, fellow student, there's a financial galaxy waiting to be explored. Here are some creative ways to make money while keeping your studies on the straight and narrow. The online hustle. Tutoring tycoon. Share your knowledge and become a tutoring king or queen. Websites like Wyzant or Chegg connect you with students who need a little extra help. Turn your study sessions into tutoring sessions and watch your earnings grow alongside your understanding of the subject. Content creation cash cow. Got away with words and can handle the challenge of cat video research? Freelance writing can be your saving grace. Platforms like Upwork allow you to write blog posts, website content, or even social media captions for businesses. Channel your inner influencer and get paid for your witty remarks. Survey says. Cha-ching! While they won't make you a millionaire overnight, survey sites like Swagbucks or Prolific can earn you some extra cash for answering questions or completing small online tasks. Think of it as a mental break that pays a little the offline grind. Part-time perks. Retail stores, restaurants, or libraries often have flexible schedules perfect for squeezing in work around classes. Plus, some offer employee discounts. Hello, student budget savior. Sell your stuff, distress yourself. Gathering dust on your shelf? Textbooks you'll never open again or clothes that haven't seen daylight since freshman year? Sell them online on platforms like Poshmark or Mercari, or have a good old-fashioned garage sale. Turn your unused items into cash for that new gadget you've been eyeing. The investment frontier for the bold, stock market samurai. The stock market can be a wild ride, but with careful research and a long-term strategy, it can also be a path to financial freedom eventually. Remember, this is a riskier option, so do your research, start small, and maybe consult a financial advisor before diving in. There are also commission-free stock trading apps that can make it easier to get started. Remember, balance is key. Don't let your side hustle turn into a full-blown meltdown. Prioritize your studies and schedule your work hours wisely. Your GPA is still important. Time management is your best friend. Plan your days like a pro to ensure you have enough time for classes, work, and some well-deserved relaxation, because Netflix marathons are important too. Bonus tip. Skills pay the bills. Learning a valuable skill like graphic design or web development can open doors to well-paying freelance gigs or internships. Plus, it looks great on a resume. Earning money as a student is totally doable. With a little creativity and effort, you can turn your free time into some serious cash. Now go forth and conquer that financial mountain, just maybe with some comfy shoes and a backpack full of knowledge this time. Thank you for watching. Stay tuned for more. Craft Epic AI Prompts. Your guide to unleashing creativity, landing your dream job, knowing you're eligible. Imagine you're a wizard, summoning a magical AI genie. But this time, the genie unlocks a treasure trove of future job opportunities tailored to your skills. Your words are the spell. With the right AI prompt, you can create mind-blowing art and stories, showcase your skills for the AI and generative AI job market, and ensure you're eligible for these exciting positions. Here's your crash course. 1. Think like a superhero, not a sidekick. What do you want your AI to create? A fire-breathing dragon illustration for a fantasy video game? A hilarious robot poem for a children's educational app? Be clear on your mission, considering the target audience and purpose. This shows potential employers your understanding of user needs. 2. Spice up your language, show off your skills. Don't just say, "Draw a dragon." Describe its fiery scales, piercing eyes, and the epic landscape it soars through, using terms like normal mapping for textures and depth of field for background effects. The more details and technical language you use, the better the AI understands your vision and demonstrates your knowledge of relevant tools. Eligibility check. Technical skills. While specific requirements might vary, having a strong foundation in programming languages like Python or R, familiarity with AI frameworks like TensorFlow, and an understanding of machine learning concepts are often essential. Soft skills, creativity, problem-solving, analytical thinking, and excellent communication skills are crucial for success in the AI field. 3. Channel your inner artist problem solver. Want a Van Gogh-inspired landscape with a twist? Mention his swirling brushstrokes and vibrant colors, then ask the AI to incorporate sustainable energy sources like windmills. This showcases your ability to combine creativity with problem solving, a key skill for AI-powered design. 4. Think outside the box. Future-proof yourself. Don't be afraid to get weird. Ask the AI to write a news report from the perspective of a talking cat using natural language processing, or design a sustainable city on Mars that utilizes generative AI for urban planning. These prompts show your forward-thinking approach and ability to adapt to emerging technologies, making you a valuable asset in the AI job market. Remember, start simple. If you're new to this, ease into it with clear prompts. Refine your spells. Don't be afraid to experiment and tweak your prompts to get the perfect results. Experimentation is key in AI. Have fun. This is about unleashing your creativity and exploring the wonders of AI. The future of AI-powered creation is in your hands, and with it, exciting career opportunities. So, grab your AI wand, craft your most epic prompt, and get ready to be amazed by the results you create and the doors it opens for your future. Remember, check the eligibility requirements for the specific AI or generative AI jobs you're interested in. Thank you for watching.
Stack organization concept. A stack is a last-in first-out LIFO data structure that plays a crucial role in computer architecture. It functions like a stack of plates, where you add plates referred as data on top and remove them from the top as well. Implementation. In the context of CPUs, a stack is typically implemented as a dedicated memory area or a set of registers. A special register called the stack pointer SP keeps track of the address of the topmost element, often referred to as the top of the stack. Operations. Push adds an element or data to the top of the stack. The SP is incremented to point to the newly added element. Pop removes the element at the top of the stack. The SP is decremented to reflect the new top element. Instruction formats. Instruction formats define how instructions are encoded in a machine's memory. Different CPU architectures use various instruction formats, typically classified by the number of operands refereed as data values explicitly specified in the instruction. Zero address instruction. Stack-based, no operand fields are present. Instructions operate on the top elements of the stack, such as implicit operands. Example: add instruction pops two operands from the stack, adds them, and pushes the result back onto the stack. Advantages: simpler instruction format, efficient for LIFO operations. Disadvantages: less flexible for complex instructions requiring specific memory locations. One address instruction, one operand field is specified. The instruction typically uses an implicit register, for example, accumulator, and the specified memory location or register for the operation. Example: add X instruction adds the value at address X to the accumulator. Advantages: more flexible than 0 address but simpler than 2 and 3 address. Disadvantages: limited operand flexibility compared to multi-address instructions. 2 address instruction, 2 operand fields are specified. The instruction typically performs an operation between the 2 operands, possibly storing the result in a register or memory location. Example: add X, Y instruction adds the values at addresses X and Y, storing the result at location X or another specified location. Advantages: more flexible than one address, suitable for many operations. Disadvantages: can be less efficient for LIFO-like operations than stack-based. 3 address instruction, 3 operand fields are specified. The instruction explicitly states the source operands, the operation to perform, and the destination for the result. Example: load X, Y, Z instruction loads the value at address Y into register X, and stores the value at address Z into another register or memory location. Advantages: most flexible instruction format, allows for complex operations. Disadvantages: less compact than other formats, potentially less efficient for simpler operations. Notations: in computer organization, various notations are used to represent data, memory addresses, and operations. Binary numbers, instructions and data are ultimately stored in the CPU's memory as binary numbers, i.e. sequences of zeros and ones. Hexadecimal numbers, hexadecimal having base 16 notation, is often used for human-readable representation of binary data due to its efficiency, i.e. fewer characters than binary for larger numbers. Assembly language. Assembly language provides a symbolic representation of machine instructions, making them more readable for programmers than binary or hexadecimal code. It is typically translated into machine code, i.e. binary instructions, by an assembler. High-level languages, HLLs, for example, C, Java, Python, offer a more programmer-friendly way to write code. They are compiled or interpreted into machine code that the CPU can understand. Let's solve some multiple-choice questions. What is the primary operation of a stack? A. First in first out FIFO. B. Last in first out LIFO. C. Random access. D. Sequential search. Solution. B. What register keeps track of the topmost element in a stack organization? A. Accumulator. B. X register. C. Stack pointer. SPD. Program counter. PC. Solution. C. Which instruction format does not explicitly specify any operands in the instruction itself? A. 0 address. B. 1 address. C. 2 address. D. 3 address. Solution. A. What is the advantage of a stack-based instruction format? A. Increased flexibility for complex operations. B. Efficiency for last in first out LIFO operations. C. Easier addressing of random memory locations. D. Reduced instruction size for simpler operations. Solution. B. What is the trade-off of using a 3-address instruction format? A. Less efficient for LIFO operations. B. Limited operand flexibility. C. More compact instruction size. D. Less flexibility for complex operations but more efficient for simpler ones. Solution. C. What notation is most commonly used for human-readable representation of binary data in computer organization? A. Decimal. B. Octal. C. Hexadecimal. D. ASCII. Solution. C. What is the role of an assembler in computer organization? A. Defines instruction formats for the CPU. B. Translates assembly language into machine code. C. Executes machine code instructions. D. Manages memory allocation for programs. Solution. B. How are high-level languages HLLs typically translated into instructions the CPU can understand? A. Directly interpreted by the CPU. B. Compiled into machine code or interpreted into bytecode. C. Manually translated into assembly language. D. No translation is needed, HLL code is directly executable. Solution. B. What is the main difference between assembly language and a high-level language HLL? A. Both offer the same level of abstraction from machine code. B. HLLs are closer to human language, while assembly is closer to machine code. C. HLLs are more efficient than assembly. D. Assembly languages are easier to learn than HLLs. Solution. B. What is the primary focus of computer organization? A. Programming languages and algorithms. B. Design and architecture of computer systems, including CPUs and memory. C. Operating system functionalities. D. User interface design and interaction. Solution. B. Thank you. Deep dive into the CPU, the brain of your computer. The CPU, or Central Processing Unit, is the unsung hero of your computer. It's the tireless worker that executes every instruction behind the scenes, making everything you do on your computer possible. This tutorial dives deeper into the world of CPUs, explaining their core functions and the concept of general register organization. The CPU in action, from instructions to results. Imagine the CPU as a conductor in an orchestra. It receives a program, which is like a musical score, filled with instructions. These instructions tell the CPU what operations to perform on data, just like the score tells the orchestra which notes to play. The CPU then follows a specific process to execute these instructions. 1. Fetch. The control unit CU retrieves the next instruction from the main memory RAM. 2. Decode. The CU deciphers the instruction and determines what operation needs to be performed: addition, subtraction, data transfer, etc. 3. Execute. The arithmetic logic unit ALU performs the required operation on the data, which might be stored in registers or fetched from RAM. 4. Store. The results of the operation are stored back in a register or a RAM, depending on the instruction. This fetch, decode, execute, store cycle continues relentlessly until the entire program is executed. The speed of this cycle, measured in clock speed GHz, determines how fast your computer can process information. General register organization, keeping things speedy. Registers are the CPU's secret weapon for speedy performance. Think of them as tiny, super-fast cubbyholes for data and instructions that the CPU needs immediate access to. Unlike main memory RAM, which is slower to access, registers can hold frequently used data or intermediate results, allowing the CPU to grab them quickly without waiting for RAM. There are two main types of registers: general-purpose registers (GPRs). These versatile workhorses can store any kind of data, be it numbers, text, or addresses. Special-purpose registers (SPRs). These registers have specific tasks. For example, the program counter PC keeps track of the instruction being executed, and the stack pointer SP manages a special area of memory for function calls and temporary data. Using registers offers significant advantages. Speed boost. Accessing data in registers is significantly faster than accessing data in RAM, leading to a noticeable performance improvement. Reduced memory traffic. By keeping frequently used data close at hand, the CPU avoids unnecessary back and forth with RAM, freeing up memory bandwidth for other tasks. However, there's a trade-off. Registers are much smaller in size compared to RAM. This means they can only hold a limited amount of data at a time. Recap: the CPU is the heart of a computer, responsible for executing program instructions. It follows a fetch, decode, execute, store cycle to process data and instructions. General register organization plays a crucial role by providing high-speed storage for frequently used data, significantly enhancing CPU performance. This tutorial serves as a foundation for understanding CPUs. As you delve deeper into computer science, you'll encounter more advanced concepts like pipelining, caching, and multi-core processors, all building upon the core principles explained here. Now let's solve some multiple-choice questions. 1. The CPU is responsible for A. Data storage, B. Executing program instructions, C. Displaying information on the monitor, D. Connecting to the Internet solution. B. 2. Which of the following is not a main component of the CPU? A. Control unit, B. Arithmetic logic unit, C. Hard drive, D. Registers solution. C. 3. Registers are A. Slow, permanent data storage locations, B. High-speed temporary storage locations within the CPU, C. Another term for main memory, RAM, D. Parts of the computer case solution, B. 4. General-purpose registers GPRs can store A. Only instructions, B. Only data, C. Both instructions and data, D. Neither instructions nor data solution, C. 5. The program counter PC register is a type of A. General-purpose register, B. Special-purpose register, C. Neither general-purpose nor special-purpose, D. All of the above solution, B. 6. What is the main advantage of using registers in the CPU? A. Lower cost, B. Larger storage capacity, C. Faster data access, D. More durable solution, C7. A disadvantage of using registers is A. They are cheap to manufacture, B. They are easy to program, C. They have limited storage capacity, D. They are not volatile, data is not lost when powered off solution, C. 8. In a general register-based CPU organization, instructions typically access operands from A. Only main memory, B. Only registers, C. Both registers and main memory, D. Neither registers nor main memory solution, C. 9. General register organization can lead to A. Slower program execution, B. More complex instruction formats, C. Faster program execution due to reduced memory access, D. Less efficient use of CPU resources solution, C.
delving deeper into memory organization. Memory organization is the intricate architecture behind how computers store and retrieve data. This in-depth guide will explore its key concepts with real-world examples to enhance your understanding. The building blocks of memory. Bits. The fundamental unit of information in a computer. A bit can be either a 0 or a 1. Imagine a light switch, either on 1 or off 0. Bytes. A group of 8 bits typically represents a single character like a letter, number, or symbol. Think of a byte as a single word you can write with 8 letters, zeros and ones. Words. A group of bytes that the CPU can process at once. Word size varies depending on the processor architecture, often 2 or 4 bytes. Imagine a word as a short phrase made up of a few bytes, groups of 8 letters. Address. A unique identifier, like a house number, assigned to each memory location. The CPU uses addresses to locate specific data within the vast memory space. Memory characteristics. Capacity, measured in bytes KB, MB, GB, TB. It represents the total amount of data memory can hold. Think of it as the total storage space in your filing cabinet. A typical computer might have 8 GB of RAM main memory. Speed, measured in nanoseconds ns, it signifies how fast data can be accessed from memory. Faster memory allows for quicker program execution. Imagine being able to find a document instantly in your filing cabinet compared to having to search for minutes. RAM is much faster nanosecond than a hard drive milliseconds. Volatility. This refers to whether data is retained when the power is off. Volatile memory. RAM loses its contents when power is lost, like a whiteboard where information is erased when you turn off the lights. Non-volatile memory. ROM retains data permanently, like a written document in a folder. The memory hierarchy. Balancing needs. Computers employ a tiered memory hierarchy to achieve a balance between speed, capacity, and cost. Cache, a very fast, small memory located within the CPU. It stores frequently accessed data for immediate retrieval, significantly reducing access time. Imagine having a small tray on your desk to hold the documents you're currently working on for quick reference. Main memory. RAM. This is faster than secondary storage and holds data that the CPU is actively using. It's volatile, so data is lost on power off. Think of RAM as your active workspace on your desk where you can manipulate documents. Auxiliary memory. Secondary storage. This provides much larger storage capacities but has slower access times. It's non-volatile, so data persists even when powered off. Imagine auxiliary memory as file cabinets in your room where you store less frequently used documents for long-term access. Examples include hard disk drives HDDs and solid-state drives SSDs. Main memory. RAM. The workhorse, directly accessible by the CPU for program execution and data manipulation. Volatile, so data is lost when powered off. Imagine leaving your work on your desk overnight. It's gone when you return power off. Capacity typically ranges from a few gigabytes to tens of gigabytes, sufficient for running programs and manipulating data in use. Auxiliary memory. Secondary storage. The archive, slower access times compared to RAM, impacting program loading and file retrieval speed. Non-volatile, data persists even when powered off. Imagine your documents safely stored in a file cabinet, ready to be accessed when needed. offers significantly larger capacities, terabytes and beyond, for storing vast amounts of data like movies, music, documents, and applications.
Examples include hard disk drives. HDDs utilize magnetic platters to store data. They are relatively inexpensive but have slower access times and are more susceptible to physical damage. Solid-state drives. SSDs employ flash memory chips for data storage. They are faster, more durable, but generally more expensive than HDDs. In conclusion, understanding memory organization empowers you to appreciate how computers efficiently manage information. The memory hierarchy ensures that frequently used data is readily available while providing ample storage for long-term needs. This intricate system is the foundation for seamless program execution and data manipulation on your computer. Multiple choice questions on memory organization with solutions and explanations. Instructions. Choose the best answer for each question. Question. The most fundamental unit of information in a computer is called a byte. B word. C bit. D address. The correct option is C. Explanation. A bit is the basic unit of information, representing either a 0 or 1. Bytes, words, and addresses are built upon combinations of bits. Question. How many bits typically make up a single character? A2, B4, C8, D16. The correct option is C. Explanation. In most modern computers, a byte consists of 8 bits and is used to represent a single character. Question. In the context of memory, what does volatility refer to? A. The size of the memory. B. The speed of data access. C. Whether data is retained when powered off. D. The type of data being stored. The correct option is C. Explanation. Volatility refers to whether data is lost when the power is turned off. RAM is volatile, while ROM is non-volatile. Question. Which of the following memory types is the fastest but has the smallest capacity? A RAM. This is correct option. B. Hard disk drive. HDD. C. Solid state drive. SSD. D. Cache. This is the correct option. The correct option is D. Explanation. Cache memory is the fastest type but has the smallest capacity. RAM is faster than HDD and SSD but slower than cache. Solid-state drives. SSDs are generally considered faster than hard disk drives. HDDs because A. They use magnetic platters for storage. B. They have moving parts that can slow down access. C. They rely on flash memory chips for faster access times. D. They are more susceptible to physical damage. The correct option is C. Explanation. HDDs use spinning platters for data storage, introducing mechanical delays. SSDs utilize flash memory for faster electronic access. Question. A unique identifier assigned to each memory location to locate specific data is called a byte. B word. C address. D cache. The correct option is C. Explanation. An address acts like a unique label for each memory location, allowing the CPU to find specific data. Question. Which of the following best represents the role of cache memory in the memory hierarchy? A long-term storage of large files. B. Storing frequently accessed data for quick retrieval. C. Holding the operating system for execution. D. Providing additional storage space for RAM. The correct option is B. Explanation. Cache memory stores frequently used data for faster access by the CPU, reducing the need to access slower main memory RAM.
Unleashing the power of direct memory access DMA controllers. In the bustling realm of computer architecture, optimizing data flow is paramount. The CPU, the central maestro, oversees everything from calculations to interactions with external devices. But when it comes to bulky data transfers, the CPU can become a bottleneck, akin to a single toll booth handling a highway full of trucks. This is where direct memory access DMA controllers come in, offering a dedicated express lane for high-speed data movement, allowing the CPU to focus on more critical tasks. The bottleneck blues. Why we need DMA? Imagine a single traffic controller managing every vehicle on a highway. This is similar to a system without DMA. The CPU, acting as the controller, handles both data processing and data transfer between itself and I/O devices like storage drives or network adapters. For small data exchanges, this setup works. However, when dealing with massive data volumes, like video editing or large file transfers, CPU involvement creates a bottleneck. Here's why. CPU burden. The CPU spends a significant amount of time managing data transfer specifics, limiting its ability to perform other tasks. Bus contention. Every data transfer requires access to the system bus, the highway connecting the CPU, memory, and I/O devices. Frequent CPU involvement in data movement leads to increased bus contention, slowing down overall system performance. The DMA controller. A dedicated express lane. A DMA controller acts as a specialized coprocessor, offloading data transfer duties from the CPU. Think of it as adding a dedicated express lane for high-speed data movement alongside the regular traffic flow managed by the CPU. Inside the DMA engine. A step-by-step look. The following steps illustrate a typical DMA transfer process. Configuration Central. The CPU prepares the DMA controller by providing details like source and destination. This specifies the location of the data to be transferred, which could be memory addresses or I/O device registers. Transfer size. The amount of data number of bytes or words to be moved is defined. Transfer direction. This indicates whether data is being read from the I/O device to memory read or vice versa write transfer mode. Some DMA controllers offer options like burst mode, where data is transferred in continuous chunks for improved efficiency. Requesting access. The I/O device initiates a DMA request when data is ready for transfer. This request could be triggered by various events, such as a completed disk read operation or a full network packet reception. Taking the wheel. The DMA controller signals the bus arbiter, a component that manages bus access for different devices. Upon receiving permission, the DMA controller takes temporary control of the system bus's address, data, and control. This essentially pauses regular CPU access to the bus for the duration of the transfer. Data on the move. The DMA controller takes over the data transfer process. It generates memory addresses in sequence based on the transfer size. It reads data from the I/O device or writes data to the I/O device using the system bus. It updates an internal byte counter to track the progress of the transfer. Job done. Once the transfer is complete, the DMA controller relinquishes control of the buses, allowing the CPU and other devices to resume normal operation. It then notifies the CPU with an interrupt, indicating the completion of the DMA transfer. The power of offloading. Benefits of DMA controllers. The advantages of utilizing DMA controllers are substantial. Performance boost. By offloading data transfer tasks, the CPU is freed up to focus on other computations, leading to a significant performance improvement. Speed daemon. Dedicated hardware on the DMA controller allows for fast and efficient data movement compared to CPU-controlled transfers. Reduced CPU overhead. The CPU is only involved in initializing and finalizing the DMA transfer, minimizing its workload. Real-world applications. Where DMA shines. DMA controllers are prevalent in modern computer systems, playing a vital role in various data transfer scenarios. Disk data transfer. DMA is essential for efficiently reading and writing data to storage devices like hard disk drives and solid-state drives. Network adapter data transfer. Network adapters rely on DMA to move incoming and outgoing network packets between memory and the network interface. This ensures smooth data flow during network communication. Audio-video data transfer. Real-time audio and video streaming heavily utilizes DMA controllers for transferring large amounts of data between memory and sound cards or video capture cards. In conclusion, DMA controllers act as unsung heroes in the world of computer architecture. By offloading data transfer tasks, they significantly improve system performance and allow the CPU to focus on more critical operations. From enabling smooth test your understanding. Question. What is the main advantage of using a DMA controller? Answers. Improved system performance by freeing up the CPU for other tasks. Question. Briefly describe the steps involved in a DMA transfer. Answers. CPU initialization, DMA request, bus takeover, data transfer, and completion notification. Question. Can a DMA controller operate without any involvement from the CPU? Answers. No. The CPU initializes the DMA controller and receives notification upon completion. Hey everyone, thanks for tuning in and learning about DMA controllers. These hidden gems really help our computers run smoothly. If you found this video helpful, consider giving it a thumbs up to let me know. And if you have any questions or thoughts on DMA controllers, leave a comment below. I'd love to hear from you. For even more tech breakdowns and interesting content, hit that subscribe button and join the community.
What is Google Gemini? A family of large language models (LLMs) developed by Google DeepMind, succeeding LaMDA and PaLM 2. 3 variants exist. Gemini Ultra, largest and most capable. Gemini Pro best for scaling across tasks, and Gemini Nano most efficient for devices released in December 2023 as a competitor to OpenAI's GPT-4. Powers the chatbot named Gemini Key Capabilities. Multimodal. Understands and combines different data types like text, code, audio, images, and video. Flexible. Runs efficiently on various platforms, from data centers to mobile devices. Availability. Direct access. Through the Gemini chatbot. Cloud integration. Developer can integrate Gemini models into applications using Google AI Studio and Google Cloud Vertex AI. Open source access. A family of lightweight, open-source models called Gemma is available for exploration, built on similar technology as Gemini. Here are some resources for further reading. Google DeepMind's Gemini page. https://deepmind.google/technologies/Gemini/ Blog post announcing Gemini. https://www.youtube. The links will be shared in description section. I hope this comprehensive explanation sheds light on Google Gemini. Feel free to ask if you have any specific questions about its features or applications. There are two main ways to interact with Google Gemini. 1. Through the Gemini chatbot. This is the method you're using right now. You can ask questions in natural language and it will try its best to understand and respond in a comprehensive and informative way. 2. Cloud integration for developers. If you're a developer, you can leverage Gemini's power in your applications. Here's how. Google AI Studio. This platform allows you to build and deploy custom AI models without extensive coding. You can integrate pre-trained Gemini models or fine-tune them for your specific needs. Google Cloud Vertex AI. This is a suite of tools for building and managing machine learning models on Google Cloud. It offers access to various AI services, including large language models like Gemini. Here's a breakdown for different users. Casual users. The Gemini chatbot is the easiest way to experience Gemini's capabilities. Just ask away. Developers. Utilize Google AI Studio or Cloud Vertex AI to integrate Gemini's power into your projects. Additional tips. When using the chatbot, be specific with your questions. The more context you provide, the better it can understand your request. For developers, explore the documentation for Google AI Studio and Cloud Vertex AI to learn more about integrating Gemini models. While there's no public mobile app available yet for direct Gemini access, it might be integrated into the existing Google app in the future. Stay tuned. The way you use a prompt. depends on the context you have in mind. Here are two common interpretations. 1. Using prompts with large language models (LLMs). In this context, a prompt refers to a piece of text you provide to an LLM to guide its response. It's like giving an instruction or starting point for the LLM to generate text, translate languages, write different kinds of creative content, or answer your questions in an informative way. Here's how to use prompts effectively with LLMs. Be clear and specific. The more precise your prompt, the better the LLM can understand your intent and respond accordingly. Provide context. If your prompt refers to specific things, characters, or situations, adding background information can improve the LLM's output. Adjust the tone. You can influence the formality, style, and even humor in the LLM's response by using specific language in your prompt. For instance, here are some prompts with different goals. Informative prompt. Write a summary of the life and achievements of Albert Einstein. Creative prompt. Compose a science fiction poem about a robot who falls in love with a human. Instructional prompt. Translate this sentence into Spanish. Hello, how are you today? 2. Using prompts in computer programming. In programming languages like JavaScript, there's a function called prompt that displays a dialog box on the user's screen. This box asks the user to enter some text and then returns that text to the program. Here's a basic example of using prompt in JavaScript. JavaScript. Const name prompt. What is your name? Alert, hello, plus name. This code displays a prompt that asks the user for their name. Once the user enters their name and clicks OK, the program stores that name in the variable name and uses it to greet the user. I hope this clarifies the concept of prompts. Let me know if you have any questions. Here are some examples of how you can use Google Gemini, both through the chatbot interface and for developers. Using the Gemini chatbot. Writing assistance. Let's say you're stuck on a writer's block for your essay on the history of solar power. You can prompt Gemini with, "Can you help me brainstorm some ideas for the conclusion of my essay about the history of solar power?" Maybe highlight its future potential. Gemini can generate creative text formats or outlines to get you going. Research and summarization. You're interested in learning more about the black hole at the center of the Milky Way galaxy but don't have time for extensive reading. You can ask, "Summarize the key characteristics and recent discoveries about the Sagittarius A black hole." Gemini can find relevant information and provide a concise summary. Creative writing spark. Feeling uninspired? Prompt Gemini with, Write a short science fiction story about a team of astronauts who discover a hidden civilization on Mars. Let Gemini surprise you with its creative take. Using Gemini for developers, cloud integration, building a chatbot. Imagine you're developing a customer service chatbot for an e-commerce website. You can integrate Gemini's capabilities to allow the chatbot to understand natural language queries from customers, answer product-related questions, or even complete transactions. Data analysis with text summarization. You're working on a data science project that involves analyzing a large dataset of customer reviews. You can leverage Gemini's text summarization abilities to automatically generate summaries of these reviews, helping you identify key themes and trends. Multilingual content creation. You need to create product descriptions in multiple languages for your online store. Gemini's ability to translate languages can be integrated into your workflow to automate some of the translation process. These are just a few examples, and Gemini's potential applications are vast. Remember, the key is to provide clear prompts or instructions to get the most out of Gemini's capabilities. Here's a real-world scenario where you can leverage Gemini's capabilities through a prompt to create unique content. You're a social media manager for a bakery and want to generate engaging content for your upcoming spring launch. Prompt: write a catchy social media post in the voice of our bakery announcing the arrival of spring with a new line of floral-inspired cupcakes. Possible response from Gemini: spring has sprung, and our bakery is blooming with deliciousness. We're launching a brand new line of cupcakes bursting with springtime flavors like lavender lemon, rose raspberry, and fragrant violet. Pre-order yours today and celebrate the season with a taste of floral delight. Spring cupcakes seasonal treats. Bakery love benefits of using this prompt. Targeted content. It specifies the bakery's brand voice and the purpose of the post: promotion, creative inspiration. It provides keywords like floral-inspired and springtime flavors to spark creative text generation. Engaging tone. It suggests using emojis and hashtags to make the post visually appealing and discoverable. This is just a starting point, and you can refine the prompt further based on your specific needs. Perhaps you want Gemini to suggest additional cupcake flavors or recommend specific hashtags. Remember, the more details you provide in the prompt, the better Gemini can tailor its response to your requirements. Here's a challenging example that showcases Gemini's potential for complex tasks. Scenario: you're a researcher investigating the potential effects of climate change on the migration patterns of humpback whales. You have access to vast datasets containing historical whale sighting data, oceanographic measurements, and climate models. However, manually analyzing these datasets and identifying correlations is a monumental task. How Gemini can help: 1. Data cleaning and preprocessing. You can develop a program that utilizes Gemini's capabilities to clean and organize the massive datasets from various sources. This might involve tasks like identifying and correcting inconsistencies, converting formats, and extracting relevant information. 2. Feature engineering. Scientific data often requires manipulation to be usable in machine learning models. You can use Gemini to help create new features from existing data. For instance, Gemini could analyze historical migration patterns and oceanographic data to generate features that represent factors potentially influencing migration routes. 3. Model training and analysis. Once the data is prepared, Gemini can be integrated into a machine learning pipeline. You can train a model using Gemini's ability to understand and process complex scientific data. This model could analyze the correlations between climate factors, oceanographic conditions, and historical migration patterns. 4. Hypothesis generation and exploration. After training the model, you can use Gemini to analyze the results and identify emerging patterns. It can help you generate new hypotheses about how climate change might be impacting whale migration. For instance, Gemini might highlight a correlation between rising sea temperatures and a shift in migration routes. 5. Scientific report writing. Gemini can assist you in summarizing the research findings and even drafting a scientific report in a clear and concise manner. It can translate complex scientific concepts into a well-structured report suitable for peer review. Challenges and considerations. Scientific expertise. While Gemini can be a powerful tool, it cannot replace scientific expertise. You, as the researcher, need to have a strong understanding of the scientific domain and interpret the results generated by Gemini critically. Data bias. Machine learning models can inherit biases from the data they're trained on. It's crucial to ensure the datasets used for training Gemini are comprehensive and unbiased. Explainability. Understanding how a complex model arrives at its conclusions is crucial in science. While Gemini can help analyze data, it's important to have additional methods to explain the reasoning behind the model's prediction. This example highlights how Gemini, when used thoughtfully alongside human expertise, can be a powerful tool to accelerate scientific discovery in complex fields. Since Google Gemini is a relatively new large language model released in December 2023, there aren't universally established, popular prompts yet. However, some general categories of prompts tend to be widely used across different LLM platforms. 1. Informative prompts. These prompts aim to gather information or complete tasks in a straightforward way. Example: summarize the key differences between classical and quantum mechanics. Another example: write a business email requesting a meeting to discuss project timelines. 2. Creative prompts. These prompts unleash Gemini's creative potential for generating different content formats. Example: compose a poem about a robot who falls in love with the moon. Another example: craft a science fiction news story set in a future where Mars is a bustling colony. 3. Instructional prompts. These prompts guide Gemini to perform specific actions on your behalf, such as translation or code generation. Example: translate this sentence into French. What are your plans for the weekend? Another example: write Python code to calculate the area of a circle given its radius. It's important to remember that Gemini responds best to clear and specific prompts. The more context and details you provide, the better it can understand your request and deliver an exceptional response. Here are some additional tips for crafting effective prompts for Gemini. Use natural language. Don't feel restricted to technical jargon. Phrase your prompts in a way that you would naturally speak. Provide context. If your prompt refers to specific things, characters, or situations, adding background information can be helpful. Adjust the tone. The way you phrase your prompt can influence the formality, style, and even humor in Gemini's response. As Google Gemini continues to evolve and gain wider adoption, specific, popular prompts might emerge based on user preferences and application areas. However, the core principle of clear and well-structured prompts will remain essential for getting the most out of this powerful language model. Google Gemini, a powerful AI language model, is poised to revolutionize many fields. Imagine AI helping writers overcome creative blocks, or scientific researchers analyze complex data. Educational platforms could personalize learning, while customer service chatbots handle nuanced requests. However, ensuring fairness, transparency, and accessibility in this AI future is crucial. With responsible development, Gemini has the potential to empower us all. Did you enjoy this video? Leave a thumbs up to let me know. Sticking around? Subscribe for more content like this.